Hatfield, England, November 25th, 1940. The airfield was silent, except for the wind scraping across the frosted grass. In a hangar that smelled of glue, resin and sawdust, a handful of engineers stood around something that looked nothing like the war machines of its time. No riveted metal, no heavy armour, just smooth, polished wood, pale, elegant, and impossibly light. At its centre stood a man in a flat cap and wool coat, inspecting every curve as if it were a sculpture. His name was Geoffrey de Havilland, and the aircraft before him would soon earn a name whispered with reverence and disbelief: the Mosquito, the wooden wonder. At a time when Britain's factories were turning out metal monsters, Spitfires, Hurricanes, bombers plated with steel, de Havilland was proposing something that seemed like madness: a combat aircraft made almost entirely of wood. It sounded like a relic of a bygone era, a fragile throwback to aviation's infancy, but the logic behind it was anything but naive. De Havilland understood what few others dared to consider. The war was consuming metals faster than Britain could produce them, and the skies were growing deadlier by the month. Wood, he argued, was not weakness, it was opportunity. Before the war, Geoffrey de Havilland had been one of Britain's most respected designers. He had built elegant civilian aircraft, the Moth series, for exploration and flight training. But when war came, the Air Ministry demanded heavier armed aircraft, bombers bristling with guns, layered in armour, and burdened with complexity. De Havilland disagreed. He believed speed and efficiency could defend a plane better than any turret. His vision was radical: a bomber so fast it wouldn't need guns, a plane that could fly higher, faster, and farther than the enemy could react. The first challenge wasn't aerodynamic. It was bureaucratic. Officials laughed at the concept. A wooden bomber without defensive guns? It'll be shot to pieces. But de Havilland refused to surrender. He built the prototype privately, using his company's own money, recruiting furniture makers and violin craftsmen to shape the fuselage with precision. When aluminium was rationed and steel was scarce, he reached for birch, spruce and balsa. Layers bonded with casein glue, a carpenter's craft elevated to the art of survival. The first flight came on November 25th, 1940, in the middle of the Blitz. German bombers were hitting London nightly, and yet here, just a few miles away, de Havilland's team was testing a design that defied every wartime doctrine. Test pilot Geoffrey de Havilland Jr., the founder's son, eased the throttle forward. The twin Merlin engines roared to life, their notes sharper and cleaner than the dull thrum of standard bombers. The Mosquito lifted smoothly into the air, faster than any British bomber before it, and more manoeuvrable than most fighters. Within months, results stunned the skeptics. The Mosquito outran enemy aircraft at over 400 miles per hour. It could carry a payload comparable to larger bombers while evading interception entirely. The first operational missions in 1941 proved the impossible. A wooden plane built by craftsmen could strike deep inside occupied Europe and return untouched. Precision raids on Gestapo headquarters, communication hubs, and even Berlin itself followed. De Havilland's design had turned carpentry into strategy. But it wasn't only about speed. Every detail of the Mosquito embodied a philosophy, a rejection of waste and complexity. Wooden construction freed up strategic metals for other aircraft. It used a decentralized workforce. Piano factories, cabinet shops, and furniture makers across Britain built parts under secrecy. It was an engineering revolution disguised as tradition, and it made the Mosquito a logistical triumph as much as a technological one. It was lighter, faster to build, and easier to repair than its rivals. The Air Ministry, once dismissive, now flooded de Havilland with orders, but even then he refused to over-celebrate. The aircraft speaks for itself, he would say quietly. He disliked ceremony and despised politics. His joy was in craftsmanship and precision, the satisfaction of seeing an idea proven by performance, not applause. To him, the Mosquito wasn't just a weapon. It was proof that simplicity, intelligently applied, could defeat dogma. The war had taught him something deeper, that innovation often begins as rebellion. When bureaucrats demanded armour, he offered aerodynamics. When they called for guns, he offered grace. The Mosquito's skin of wood masked a truth that every engineer understands. The material doesn't define the strength, the design does. As the Mosquito's legend grew, so did the risks. Each success invited more dangerous missions, low-level strikes, photo reconnaissance runs, precision bombings through flak and fire. Pilots trusted the aircraft like a living being. They called it a miracle. The Luftwaffe called it the fastest pest in the sky. De Havilland called it simply good engineering. In his quiet way, Geoffrey de Havilland had reshaped the logic of air combat. He had built not just a machine, but a philosophy. One that valued speed, elegance, and intellect over brute strength. The Mosquito wasn't merely a plane, it was a statement that innovation thrives where convention fails. If you believe history is written not only by soldiers, but by thinkers and builders, like this video and subscribe to help uncover more stories of the men who engineered victory, one blueprint at a time. Because here's the question that lingers. Was the Mosquito's success a triumph of genius or a miracle born of desperation? Factories were burning, ports were blockaded, and yet de Havilland promised the Air Ministry he could build an aircraft faster, lighter and cheaper than any metal bomber in service. It sounded like arrogance. In reality, it was mathematics. A structure made of layered birch and balsa could absorb vibration, resist cracking, and weigh half as much as aluminium. The trick was glue, chemistry as strategy. Across Britain, small workshops that once made cabinets, violins, and pianos turned into secret production lines. Women mixed resin in kitchens. Carpenters shaped wing panels with handplanes. The process was simple to teach and hard to perfect. Each pair of wooden shells formed a fuselage so smooth it needed no rivets. In an age obsessed with metal, the Mosquito's skin was a rebuke to convention. Every component passed through the same hands-on ritual. Sections were trucked by night through narrow roads, hidden under tarps to avoid enemy reconnaissance. At Hatfield, final assembly lines hummed like an orchestra. Glue brushed, clamps tightened, layers pressed, the smell of spruce heavy in the air. Workers called it building furniture that fights. De Havilland walked the floor silently, adjusting a joint here, inspecting a curve there. He believed engineering should feel human, precise, tactile, almost artistic. The first production aircraft rolled out in early 1941. Even then, doubts lingered. Could a wooden plane survive in the freezing, thin air over Europe? Could it withstand cannon fire or flak bursts? De Havilland answered not with speeches, but with data. He flew test models into turbulence, pushed the wings to near failure, and brought them home intact. The results spoke louder than propaganda. The Mosquito could dive at speeds over 400 miles per hour without shaking apart. It was light, but not fragile. Strong because it flexed, not because it resisted. Soon the Mosquito wasn't just one aircraft, it became a family. Bomber, fighter, reconnaissance, pathfinder. Its versatility astonished commanders. It could carry a full bomb load to Berlin and return faster than enemy interceptors could climb. Cameras replaced guns, guns replaced bombs. It adapted to every role thrown at it. Factories scaled up output under air raid sirens, replacing destroyed jigs overnight, keeping production alive even when cities fell dark. In 1942, when American officers visited Hatfield, they were stunned. They expected an industrial complex of furnaces and presses. They found carpenters, glue vats, and women sanding wings by hand. One observer wrote, "It was like watching art defeat war." The Mosquito's success was a logistical revolution as much as a technical one. It proved that distributed manufacturing, thousands of small hands building one great machine, could outpace centralized industry. But progress carried a price. De Havilland's eldest son, Geoffrey Jr., served as a test pilot, pushing prototypes to their limits. Every flight was a gamble. In the summer of 1943, while testing a high-speed Mosquito variant, the aircraft broke apart mid-air. The loss devastated him. He said little in public, but colleagues saw the change: quieter walks on the airfield, longer hours at the board. He poured his grief into refinement, into ensuring no design flaw could repeat such tragedy. For him, perfection was not pride, it was protection. By 1944, more than 7,000 Mosquitoes were in service across every front: Europe, Africa, Asia. They bombed Berlin in daylight, photographed Normandy before D-Day, and guided heavy bombers through cloud and flak. The Germans nicknamed it the Wooden Ghost. It had become the embodiment of de Havilland's belief that intellect could outrun brute force. Every engineer of that era faced a moral shadow. How far should creation serve destruction? De Havilland answered in craft, not words. He saw the Mosquito as proof that design excellence could save lives by precision and speed, by ending missions in minutes instead of hours of exposure. He often told young apprentices, if you build it right, the rest will follow. And history proved him right. But the war was far from over, and the skies were changing fast. Jet engines were no longer experiments, they were promises. De Havilland's wooden marvel had mastered propellers, yet the future roared with fire and thrust. Could a craftsman of wood survive the coming age of metal and flame? England, September 1945. The war was over, but the hangars did not fall silent. Where bombers once waited for orders, a new sound began to echo. Sharper, colder, unnatural. It wasn't the hum of piston engines, but the hiss of jets. Geoffrey de Havilland stood at the edge of the runway, his coat pressed by the wind, of something the world had never truly seen before: the future of flight. The machine before him was compact, silver, and deadly fast. Its name was the de Havilland Vampire, and it was about to make Britain the second nation on Earth to fly a jet fighter. The transition from wood to metal was not a step forward for de Havilland. It was a leap across an abyss. For years his world had been carved from spruce and glue, crafted by hand. Now he faced engines that melted alloy, wings that warped under heat, speeds that turned air into resistance strong enough to tear metal apart. But to him, it was still the same challenge: make something that shouldn't fly, and make it fly perfectly. While the world celebrated peace, de Havilland refused rest. He had already begun to think beyond the Mosquito, beyond even war itself. The next battle would not be for survival, but for the skies of the future. The Vampire was born from that vision, a single-seat jet built not for spectacle, but for mastery of simplicity. A twin-boom tail, a compact fuselage, and a single Goblin turbojet engine at its heart. It looked alien compared to the planes that had won the war, and when it took off, for the first time in 1943, it shattered every notion of what British aviation could achieve. The jet age had begun, quietly, without ceremony, on a grey English runway. By 1946, Vampires were flying with the Royal Air Force, replacing propeller-driven fighters across Europe. The aircraft became a global export, flying under dozens of flags from Sweden to India. De Havilland's company was no longer just building aircraft. It was defining the language of speed. But Geoffrey was not content. The Vampire was only the beginning. He wanted to build something that could carry civilians, ordinary people, into the age of jets. No more roaring engines over battlefields, no more bomb racks and armour plates. He dreamed of smooth metal, pressurised cabins, and altitudes so high that the world curved beneath the wings. It was a dream few believed possible so soon after war. But de Havilland had never been the kind of man who waited for permission. By 1949, his team revealed a vision that stunned the world: the de Havilland Comet, the first commercial jet airliner. It was the promise of a new era. Flight that would shrink the world, erase oceans, and make time itself seem smaller. Sleek, white, and silent, the Comet looked like something from another planet. Newspapers called it the future in metal. For de Havilland, it was more personal. After years of building machines to destroy, He was finally building one to connect. The Comet's first flight on July 27, 1949, was a moment of triumph, but also of transition. Britain had led the jet age, ahead of America and the Soviets. Pilots who had once fought in Mosquitoes now flew businessmen over continents. The same company that had built the Wooden Wonder was now creating the symbols of post-war peace. Yet progress rarely comes without pain. The Comet's early service was marred by tragedy. In 1954, a series of mysterious mid-air explosions destroyed several aircraft, killing everyone aboard. The same precision that had made de Havilland a legend now turned against him. His engineers worked night and day, dissecting wreckage, testing every panel, chasing an invisible enemy in the sky. It wasn't sabotage or engine failure. It was something no one had predicted: metal fatigue. The press called it a disaster. De Havilland called it a lesson. The Comet's failure forced the entire industry to confront the unseen forces that tore aircraft apart at high altitude. The heartbreak of those losses would lead to stronger designs, safer jets, and the birth of modern aeronautical engineering. In private, Geoffrey felt the weight of those deaths as deeply as the victories that had come before. "We learn only by building," he said quietly. He never blamed his team, never surrendered to politics. He simply returned to work. The redesigned Comet, the Mark IV, would go on to fly safely for years, paving the way for every airliner that followed. Through the triumph and tragedy of that era, one thing remained constant: de Havilland's belief that courage and precision could coexist. To him, innovation was not the absence of failure, it was the mastery of it. If you believe stories like this should never be forgotten, like this video and subscribe to Honor the Minds who built our modern world from nothing but imagination and risk. Because the question remains, was Geoffrey de Havilland's greatest creation the machines he built, or the courage to keep building after they fell? Hertfordshire, England, September 27th, 1946. The runway was quiet. Fog drifted over the fields as a silver aircraft stood waiting, its skin gleaming like a blade. Inside the cockpit sat Geoffrey de Havilland Jr., son of the legendary engineer, wearing his flight helmet and calm expression. A man trained to push beyond fear. The aircraft before him was the DH-108 Swallow, a delta wing jet designed to break the sound barrier. For the de Havilland family, this was not just another test. It was the frontier between genius and danger, between invention and mortality. The DH-108 looked like no plane before it. Swept wings, no tail, a cockpit barely larger than the pilot himself. It was Britain's most radical experiment, an attempt to master supersonic flight before America or Germany could claim the skies. For Geoffrey Sr., the project was deeply personal. He had watched the war push technology to its limits, but peace offered a new race, a race for speed, altitude, and understanding. The Swallow was to be his next step toward the future. At 4:30 that afternoon, Geoffrey Jr. pushed the throttle forward. The Goblin engine screamed as the Swallow accelerated down the runway, then lifted effortlessly into the haze. Ground observers watched as it climbed, levelled, and began a high-speed pass over the airfield. It moved too fast for the human eye to follow. A silver streak cutting the sky. Then, without warning, the aircraft buckled mid-turn. The wings snapped clean off. A white vapour trail twisted in silence before fragments rained to the ground. When search teams reached the crash site, there was nothing left to recognise. The DH-108 had disintegrated at over 600 miles per hour. Geoffrey de Havilland Jr. was dead at 30 years old. The man who had flown his father's dreams into the jet age had paid the ultimate price for progress. The tragedy struck Geoffrey Sr. like a physical blow. He walked the wreckage himself, silent, refusing to speak for hours. Colleagues later said he picked up a piece of twisted metal and stared at it as if trying to read its confession. The investigation revealed that the Swallow had likely suffered compressibility failure, a phenomenon still poorly understood at the time, when approaching the speed of sound caused shockwaves to destroy lift and control. In truth, the DH-108 was a victim of its own ambition. Britain was testing the edge of physics without the safety data or wind tunnel capacity of larger nations. But for Geoffrey, failure was never a reason to retreat. Within months, another prototype was built. It too crashed, killing its pilot. The third and final DH-108 managed to survive longer, gathering valuable data that would later inform safer designs. The price of that knowledge was measured in lives, and in silence. For de Havilland, the loss of his son reshaped everything. The company that had once pulsed with ambition grew quieter. The laughter of engineers at Hatfield was replaced by the hum of caution. Yet even through grief, Geoffrey kept his purpose. He continued to refine the Comet, to improve its structure, and to ensure that the lessons of every fall became the foundation for safer skies. His stoicism was legendary. When journalists asked how he found the strength to keep building after such losses, he simply replied, "Because others must fly." It was not pride that drove him now, it was responsibility. The same precision that had defined his work became a shield against despair. He poured his pain into progress. The 1950s brought de Havilland new challenges. Competitors like Boeing and Douglas began dominating the civilian jet market. The Comet's early tragedies had tarnished Britain's lead, and the government grew impatient. Yet Geoffrey refused to compromise his methods. He insisted on learning, not racing. "The future," he said, "belongs to those who test carefully, not those who arrive first." In time, history would prove him right. Every major airliner built after the Comet incorporated the lessons learned through de Havilland's heartbreak: rounded windows, reinforced pressurization, fail-safe designs. The cost of that wisdom was immense, but the impact was eternal. Geoffrey de Havilland was no longer the young craftsman of wood and glue. He was a man who had seen the future, and buried part of himself in its making. The engineers who worked with him said his silence spoke louder than any leader's speech. In the testing hangar, a small brass plaque was later installed. It read simply, "For those who gave their lives to flight." The Swallow's wreckage was long cleared, but its legacy remained. In the supersonic aircraft that would follow, in the courage of those who dared to fly faster than fear. And so the question remains: was the jet age born from innovation, or from sacrifice too great to measure? Hatfield, England, 1963. The workshop was quieter now. The same hangars that once echoed with hammers and engines now carried only the soft hum of tools and the low murmur of engineers. Geoffrey de Havilland walked the factory floor slowly, pausing to run his hand along the fuselage of a new airliner. He was older, thinner, but his gaze was still sharp, the gaze of a man who had lived his life one design at a time. Around him stood a generation of young engineers who had never known a world without flight. For them, aircraft were just machines. For him they were history, memory, and faith combined in steel and sky. It had been more than 50 years since he'd first carved wood into wings. The boy from Buckinghamshire, who once built model planes in his garden, had changed how humanity moved, fought, and connected. From the fragile mosquito that outran death, to the comet that touched the edge of space, his work had defined the century. Yet he remained humble to the end, refusing titles or self-congratulation. An aircraft, he often said, should speak for itself. The world had changed faster than even he could have imagined. The Cold War divided nations, space rockets replaced bombers, and aviation grew into a global network. But the same principles that guided him through war and tragedy endured: precision, simplicity, and courage in creation. He believed technology was never the enemy, only the misuse of it. The same wings that once carried bombs could now carry hope, trade, and human connection across continents. By the time he retired, de Havilland had seen his company merge into larger empires of industry. Names changed, logos changed, but his fingerprints remained on every modern aircraft. engineers around the world still studied his designs to understand one thing: how elegance could coexist with power. In flight schools and museums, his Mosquito still gleamed under soft lights, the wooden skins smooth as when it first flew. Veterans who once piloted it spoke of it with reverence, not nostalgia. It was alive, one said. It forgave mistakes. For Geoffrey, recognition came late. In 1944 he had been knighted, but he rarely spoke of it. He preferred the company of draftsmen and test pilots, men who understood that perfection was not glory, but discipline. When asked once how he wanted to be remembered, he replied, "As a builder of useful things." On May 91st, 1965, at the age of 82, Sir Geoffrey de Havilland passed away in peace. The newspapers called him the father of modern British aviation. Colleagues called him something simpler, a craftsman of the sky. In Hatfield, the factory flag flew at half-mast, and for a single minute production stopped. Workers stood among half-built aircraft in silence, listening to the echo of engines that would never sound again. But legacies, like flight, never truly land. The Mosquito became a symbol of intelligence over force. The Comet became the ancestor of every jet that followed. And de Havilland's philosophy, that design is the art of solving problems beautifully, still guides those who dream of the sky. He had lived through the age of wood and glue, witnessed the birth of jets, and laid the foundations for supersonic and space travel. Few men had seen so much change. Fewer still had shaped it with their own hands. The story of Geoffrey de Havilland is not only the story of flight, it is the story of what happens when persistence meets imagination, when science meets soul. He built machines, yes, but he also built bridges between generations, between war and peace, between earth and sky. As his aircraft still rest in museums, their wings casting long shadows under bright lights, one question endures. The same question that defines every age of invention. Did Geoffrey de Havilland simply master flight, or did he redefine what it means to dream?